Okay, here is a free response question involving this power series and some questions about it. We'll start with, I guess we should start with A. That sounds reasonable. A says find f prime of 0. So here's the function. F prime of 0 would be, we have the derivative of 1, 0, minus 2x over 3 factorial plus 4x cubed over 5 factorial. And that's really enough because we're going to plug in 0 to the derivative. And when you plug in 0 to the derivative, it's going to be 0. So I should really say that this is f of x. So f of 0 is going to be 0. F double prime of x will be the derivative of this, which is just the coefficient, negative 2 over 3 factorial plus 12x squared over 5 factorial, and so on. So f double prime of 0 is going to be, all the terms with the x's are going to be 0, so it's just going to be negative 2 over 3 factorial. So the next question is, do we have a local minimum or maximum or neither, or x equals 0? So you have to remember, this really involves a second derivative test. Remember, local or relative mins and maxes can only occur at critical numbers. So first of all, and I missed my prime here. First of all, this says 0, there's a critical number x equals 0, and this says the second derivative is negative. So if the second derivative is negative, that means it's concave down, so that critical number must be a relative max. So you would say we have a local max at x equals 0 because f prime of 0 equals 0 and f double prime of 0 is negative. So there's part A. Let's look at part B. Part B says show that 1 minus 1 over 3 factorial approximates f of 1 with an error less than 1 over 100. So this looks like a Lagrange error or a alternating series test error. So let's look at the series again. The series is definitely an alternating series. So by the alternating series remainder theorem, the error is always within the value of the first omitted term. So if we're looking at 1 minus 1 over 3 factorial, f of 1 would be this. Let me plug 1 in for all the x's. This indicates we're just using the first two terms to approximate the sum, and the alternating series remainder theorem says that has to be within the first omitted term, which is 1 over 5 factorial. So to put it in their terms, we can say that the actual value f of 1 minus our approximation is less than or equal to this first omitted term. 1 over 5 factorial is 2 times 3 times 4, 24 times 5, which is 120. And that is most definitely less than 1 over 100. So there you go. It brings us up to part C. Part C says show that this f of x is a solution to this differential equation. So it looks like a complicated question. We're not going to solve any differential equations. That would be impossible. We're just going to plug it in. So it's like if you had show that x equals 5 is the solution to the equation 2x equals 10, you plug 5 into x and you show that is equal. So we're going to plug in y and y prime into this side and show that somehow it equals cosine. So let's first figure out what should we do. X, y prime is. So y prime would be the derivative of this, which we already started to figure out. It's going to be 2x over 3 factorial plus 4x cubed over 5 factorial. Oh, I'm sorry, I missed that negative. And minus 6x to the 5th over 7 factorial. It's not looking like anything right now. I'm going to take the general term and also do that. Negative 1 to the n times 2n x to the 2n minus 1 over 2n plus 1 factorial plus. So that's y prime. I need to figure out what x y prime is. So all I'm doing is multiplying by x. So let's multiply every term by x. So this is starting to become a mess. 2n minus 1 plus 1 would just be 2n. But that's x, y prime. Now I have to add it to y. So I'm going to, probably the best way to do this is I'm going to do this, just write down y and add the two series vertically. So y is just going to be what the series was initially. So I'm just going to copy that down. And you can see that we're going to have a lot of like terms, which is a really good sign. So I'm just copying down this series. And now I'm going to add. So x, y prime plus y equals, add up and down. So 1, these are like terms. So I have negative 2 and a negative 1 is negative 3. 4 plus 1 is 5. This is looking nice. Negative 6 minus 1 is negative 7. So you can really see the pattern developing here. Even with these terms, we have 2n. The only difference between these two terms is this 2n and this 1. So we have negative 1 to the n times 2n plus 1 x to the 2n over 2n plus 1 factorial. So it looked like a daunting task to begin with, but it just comes down to this. This would be 2 factorial. This would be 4 factorial because the 3 and 3 cancel, 5 and 5 cancel, and so on. I don't know why I put this negative here. I already had it. So x to the 6 over 6 factorial, all the way up to this term, this general term, which is, these would cancel. So I have just the 2n plus 1 would cancel though. So I would have, hold on a second, over 2n plus 1 with this 2n plus 1, that would be 2n. All right, so now look at this series. It's all even, basically, and alternating signs. It looks like one of the power series that we should know. It's either sine or cosine. It's even. So remember, the cosine is the even function. So this does equal cosine. And, the first clue that it was going to equal cosine is that's what it says it has to equal. So that's it. So it wasn't too bad. Just a lot of work up this way, but it worked out.